Hello, guys. So given a second order differential equation of the form a d2y dx squared plus b dy dx plus cy is equal to 0, where a, b, c are constants, then how exactly do we go about the solutions? Now, this is what we'll be doing. We'll be carrying out the following replacements as we solve. We will let d2y dx squared be equal to d2, and dy dx, we will replace this with d, and y we will replace with 1. So note that. Now, this is an example. To solve this, so this is what we are going to have: 2d2 plus 5d minus 3 is equal to 0. Then I'm going to replace the value of d with m. So replace d with m, such that this will give me 2m squared plus 5m minus 3 is equal to 0. And we call this the auxiliary equation. Now, to solve the auxiliary equation, we basically just solve it using the quadratic formula. So m will be equal to minus 5 plus minus the square root of 5 squared minus 4 times 2 times minus 3. All this divided by 2 times 2. And if we solve that correctly, then we will be able to get our values of m to be m is equal to 1/2 and m is equal to minus 3. These are the roots of this particular equation. Now, depending on the roots that you've gotten, there's a general formula for writing your complementary function, or just writing the general solution. So in here we have the roots here. So the roots, as we can see, are real and different. So for real and different roots, the general formula for writing the complementary function is given by real and different roots. So if you have, m is equal to, let's say, alpha, and m is equal to beta, then your YC general solution, your complementary function, is given by a exponential alpha x plus b exponential beta x. So our answer will be given by our general solution of this particular question is y is equal to a exponential, our alpha is the first root, which is 1/2 x plus b exponential, our second root, which is minus 3, actually, not minus 2, minus 3x. That is the solution. Now, the roots don't have to be real and different all the time. You could evaluate your answer and get that the roots are probably, so the roots could be real and same. So if you have real and equal roots, let's say you have your m is equal to alpha twice. So m is equal to alpha and m is equal to alpha again. Your general solution y will be given by exponential alpha x multiplied with ax plus b. And let's also say you get complex roots. So for complex roots, your general solution y, so let's say your complex roots are m is equal to alpha plus minus beta j. Then your general solution y will be given by exponential alpha x, where alpha is the real part, into a cos beta x plus b sine beta x, where beta is the imaginary part. Now note that this is the general solution. If the question asks for the particular solution, then it means some boundary conditions have been given. So let's take up an example, same example still. So given this second order differential equation, 9 d2y dx squared minus 24 dy dx plus 16y is equal to 0. Find the particular solution. Find the particular solution given the boundary conditions, that x is equal to 0, that when x is equal to 0, when x is equal to 0, y is equal to dy dx, which is equal to 3. Now the procedure is the same for finding the general solution, and after finding our answer, then we are going to replace or put in the boundary conditions. So in order for us to solve, we are going to let d2y be d2, so 9 d2 minus 24d plus 16 is equal to 0. Then replace with m to get the auxiliary equation. 24m plus 16 is equal to 0. Okay, so we are going to solve this using the quadratic formula. So our m will be equal to minus 24 plus minus the square root of minus 24 squared minus 4 times 9 times 16. All this divided by 2 times 9. 2 times 9. And if we solve this correctly, we will get that our value of m is equal to 4 over 3 and m is equal to 4 over 3. So m is equal to 4 over 3 twice. And what is the general solution when you have the roots being real and equal? That's how we write the general solution. So the general solution y will be equal to exponential 4 over 3x of ax plus b. This will be our general solution. But the question is asking for the particular solution, so we will replace the boundary conditions. It says that when x is equal to 0, y is 3. So let's start with replacing that. When x is 0, y is 3. So if we start by that, when x is equal to 0, y is equal to 3. So let's replace it here. Y is 3, x is 0. If we replace 0 here, we'll have exponential raised to power 0, which is 1. X is 0, so this will give us 0 plus b. So clearly this gives us b is equal to 3. Okay, the next condition is that when x is 0, dy dx is 3. So when x is 0, we've been told that dy dx is 3. So let's start by getting dy dx. dy dx is the derivative of this. Now, in order for us to differentiate, we can use product rule. So let this one be u and let the whole of this be v. Then the product rule formula is u prime v plus v prime u. Okay, so differentiating u, we have 4 over 3 exponential 4 over 3x multiplied with v, which is ax plus b, plus v prime. Differentiating this with respect to x will give us a into u, which is exponential 4 over 3x. Replacing the values, we've been told that when dy dx is 3, x is 0. So replacing 0 here, we'll have 1. So that will give us 4 over 3. Replacing 0 here, so we'll have 4 over 3b. Replacing 0 here, we will have 1. So 4 over 3b plus a. But from this first point here, we know that the value of b is 3. So replacing 3 here, so we have 3 is equal to so 3 is equal to 4/3 multiplied with 3. That will be 4 plus a. So what's the value of our a? Our a is clearly equal to -1. So to find the particular solution, we replace the values of the constants. Our general solution was y is equal to exponential 4/3x into ax plus b. Okay, so our particular solution will be y is equal to exponential 4/3x into what's the value of a? -1. So minus x plus what's the value of b? 3. And this is our particular solution. So that's how you go about solving such.